All right, wanted to continue this talk on what is gravity in terms of visualizing what's actually going on, as opposed to just talking about the obvious relationships between massive objects. You know, what is it that gives an object mass? One of the things that you might think about, might want to ask, for instance, your chemistry teacher. I guess it wouldn't matter if it's a high school chemistry teacher or professor at the university. You're going to want to ask, okay, let's suppose this is the up there in the corner there, this thing looks like a flower kind of. Where is it? There it is. Okay, that represents the fluorine atom. You got your 7 protons and you have 7 electrons. And the box represents that empty spot in the outside orbit there that wants so bad to have another electron. But the problem is, with the 7 protons and the 7 electrons, you have a neutral charge. You have no net charge effects. So there's no reason for that empty orbit to want to be filled in terms of charge, because the atom's neutral and there's no charge drawing anything to the nucleus at that point. So we got to ask ourselves, you know, what's causing that void. Now, one of the things we might entertain is the possibility of some other force. There's something about the way space is shaped at that point that would attract another electron. It's not being attracted charge-wise. It's not being attracted electromagnetically. This has been a sort of mystery in elementary chemistry in the Standard Model for 100 years or so. So why don't we explore that mystery? Let's talk about what could possibly be the force that wants that orbital filled, because we know that it's not charged. So one theory, for instance, if you ever heard of any Nissim Harameen teaching on the proton as a black hole, that would make an interesting candidate for what would be a force that would attract an electron. Now remember, this is attracting an electron into a neutral field against the 7 7 negative charges that are there already. So if anything, you would think that it wouldn't. The last thing it would want is another electron. So there's something else going on there, and it seems to me that it has something to do with the shape of space in that area, or it's very possible that what we call space, as you all probably know by now, is there's no such thing as a vacuum. You have vacuum's relative, and it's only speaking about certain aspects. 0-point energy of vacuum space is extremely dense, and in many calculations it looks like it's infinitely dense in terms of the energy of empty space. So whether or not that ties into gravity, I'm not sure. However, I think it's a similar phenomena. I want to talk about gravity in terms of galaxies. Okay, now here's my little drawing of some galaxies, and notice that the two spiral shapes there have different orientation. And actually, here's a third one. Now, the third one, I added some more graphics. I'll explain those graphics later, but right now, we all know that, you look into a photograph of a deep space observation, and we see your galaxies, and there seem to be in all kinds of different orientations. There doesn't seem to be a sort of one plane that they're all sitting on, or any particular plane at all, like a sphere or a curve of any sort. They just seem to be pretty like a hodgepodge, like a Brownian motion type of orientations. So that's something else that has to be taken into consideration. Now, whirlpool, and let me explain this other graphic here. This would look something like, probably be oriented something like this. And you see, looks like whirlpools there, or tornadoes. I'm using sort of a tornado model or whirlpool. And let's suppose that there's a large black hole in the center of the galaxy. Okay, well, the galaxy, it cuts through the plane. If you're looking at a galaxy horizontal, from the horizontal plane, you have sort of you have space above it and space below it. So how's everything pouring into a black hole? It doesn't come out the other side. It's pouring in from both the top and the bottom, right? Think about that. It's coming in from the top and the bottom. It's not like a drain in say, a bathtub. When you pull the plug in a bathtub, you get the whirlpool, and of course you know that it spins. I think it's clockwise in the northern hemisphere and counterclockwise in the southern hemisphere. The whirlpool, we believe, has its rotational momentum given to it from the spin of the Earth. But what's spinning? Okay, what's spinning to give the the vortices in a black hole? So you might say, well, the black hole itself is spinning, but what's causing the galaxies to spin? See, there's not a like universal rotation necessarily. That all the galaxies spin in one direction, and in a certain hemisphere or another direction, and the other side of the universe or something like that. It seems to me that these rotations are local in terms of their the source, the source of the rotational momentum of the galaxies. But if it's due to like I have in these diagrams, like a whirlpool effect, where you have space attracting matter in, where's it going? It seems to me that you would reach a certain density, and it would stop. It would sort of it would block up, so to speak, but just keeps going in there. I think that it's going in to a larger dimensional realm. That there's, in a sense, you could say it's an infinite depth to the black hole, not like it's usually described as infinite density. I'm saying infinite depth as opposed to infinite density. But I guess my whole talk here is just to consider, play around with some ideas about where the galaxies are getting the rotational momentum, if it's a black hole whirlpool type effect, you have to ask the same question. You know, we know on Earth the whirlpool is, we believe, is the spin of the whirlpool is caused by the rotation of the Earth. But how about in a galaxy? Now, the other thing I was talking about before in terms of what is gravity, the shape of space is involved. We know, for instance, with Einstein's relativity equations and so forth, you have the warping of space-time continuum. But you think about this, it warps. What's happening is, in effect, mass is causing a lower density in the gravitational field. The way my model set up, you have a higher density outside of the mass, and the lower density is within the mass. However, the mass is circulating. In my model, you got the mass circulating 0-point energy through itself, and causing the kind of a draw that you would get from a low pressure. So you actually have mass, creating a low pressure in sort of the gravitational field. And the gravitational field, the way I'm describing, is actually the 0-point energy, the quantum foam, or whatever you want to call it, that's actually being, well, let's put it this way, this coming out of equilibrium with the presence of a massive object lowers the density. Somehow, there's something about mass that I'm describing that way. It requires this flow through of the quantum 0-point energy. And then the whole purpose for this talk is just to explore some of the mysteries and trying to give, make it so that we're not confined and restricted by scientific dogma of the standard models. Let us use our imaginations and our intuition and think about these things. Something as primary as the attraction of an outer orbit for an extra electron. If it's if it's one shy, or if it doesn't have 8, or whatever the outer orbit we're talking about at the time, is not a force that's due to anything that's described in the standard chemistry models. And likewise with gravitation, I think. I would like to, that's the kind of person I am. I want to explore the mysteries of the creation of the universe, as opposed to digest what others have come up with. I'm interested in what others have come up with, but we're not gonna. You don't make you don't make progress by sweeping the mysteries under the carpet and just sort of clinging to mathematical models that have no visualizable aspect to them. So I hope people find this interesting. I'm surprised actually that the first 2 parts of the series have been as popular as they are. So I figured I would add anytime I get a significant amount of new thoughts on the topic. And of course, I'm open to hearing what other people have to say about it. I really enjoy Nisam Harriman's interpretation of things. I think that he's onto something that's certainly worthwhile continuing to explore. I just want to add these new sort of novel ideas to the corpus of knowledge and on the YouTube, the world of YouTube, where this kind of thing is actually acceptable, if not encouraged. So I hope you enjoyed it.